Hi all. In this session, let's discuss about a project flow. I'm sure that even though you are working for multiple years in your project, sometimes some of us don't know about the complete architecture or complete flow of your project. And what are the technology stacks you are using in your project? What is the specific reason why you are using those technologies? Even actually this is expected even we are working in a project, and sometimes we are working some partly and we are not able to get time to understand the whole flow, and even we didn't get chance to see the all code flow. What are the microservices, what are the components they are using? It is really tough to understand. So even you, if you are a fresher or experienced person, this session is going to be help to all actually. So I thought I will upload a session. I am going to explain a common project. So I have taken a banking project example. So you take any banking project in IT industry, the flow will be similar. If you are using the technologies Java, it's a Java project. So I'm going to explain the technology you are using, specifically Spring Boot microservices along with Spring Cloud and some little bit AWS components and all. So this kind of project I'm going to explain, and I am going to explain all layers. What are the layers will be, what are the components will be, what are the microservices will be involved, how they are communicating to each other, what are the technologies you are using, and why you are using all these things. I am going to explain. This session going to be really helpful, not only to explain the project flow in your interview, any of the interview, but also it will be give a very basic and concrete example and concrete explanation how to like it will be give a overall idea about the project. Okay, so for you already I have designed a architectural view of a banking project. Let me explain here. And you take any of the project, there will be a UI layer, and you can say it is developed in Angular or React JS. A customer or user wanted to access your application by using a net banking or a mm, mobile banking, or by using a third party libraries or third party applications. So whenever any request will come, it will go to a specific microservices, right? So as your application is microservice based application, so you are having multiple microservices, 20 to 25 microservices in your application. Each microservices independently running, and they are not using any common database. So anyway, any request will come, it will go to a specific microservices, and before that a middleware service called centralized API gateway will take your request, and it will validate whether your request is valid or not. Not only it will validate, it will routing actually which specific microservices it will hit. It will routing, and it will apply the load balancing, traffic control. So multiple role and responsibility this API gateway is doing. So here you can use Spring Cloud API gateway. Here you can say we are using Kong or Nginx. Kong is very popular. So it is actually doing all these things, and before hitting into the particular services, then each services having their layers, like controller layer, service layer, which is having controller layer means your REST call is hitting that particular request to a particular controller, and from that controller it will go to business logic, that is called service layer, and service layer will communicate to repository layer, then it is DB. Two types of communication here in between microservices: synchronous and asynchronous. So synchronous communication means it needs immediate response, and asynchronous communication means like a bank customer wants the bank statement or a historical data where he requested to the bank, and bank will tell that will send you the bank statement within 4 working hours. So they have taken the request and they will process batch wise. So it like it's this kind of communication is known as asynchronous communication. And synchronous communication means you make a order, and your order will be success if the payment will be success. For one example I'm giving, so here order service talking to payment service. Once the payment service will respond back, then order will be success. So this kind of communication is synchronous. So here for all synchronous call, like one microservices to another microservices, whenever calling the synchronous call, we are using REST. And any asynchronous call, we are using Kafka is very robust and powerful. It is very secure, and it will be very consistency. It will send your data very, like they are using this partition. Either Kafka architecture you need to understand properly. Okay, so why you are using, because any event driven is happening, your notification is going bunch of data. So even your system is down, that times Kafka is ready to store some messages, some information, so that it can send to the customer. Even the service is down whenever it is up. So a lot of things is Kafka doing. So here we are using that Kafka for asynchronous communications. So any call is happening, as I told you, JWT we are using for authentication and authorization. Why JWT, they will ask. You can say JWT is very lightweight and stateless. So stateless means what? Any request will come from the client or from a browser. So that for that, but first time the request, right, it will go to server. It will validate whether you are mm, correct, you are you are the right person or not. Then a request, a session, a token ID will be created by the server, and it will send back to the first time auth service will be uh, call, and it will validate whether by using that credential whatever you asked that, so whether you are a valid user or not. So once the request will go, initially it will create a JWT means JSON, Java web token, actually JSON web token. Okay, so it will create a token and it will attach to the request, and going forward any API call will happen, that token will be attached. So it will be managed in cookies, it will not store in the service, and that token will be expired after few minutes, like generally it is 15 minutes as you configured at the time of token creation. So that JWT is very lightweight. That's what we are using JWT for authentication and authorizations. So each microservices individually working independently, and the database is, they are not using any common database, you can say. So because why we are using multiple database, here you see in this application, so we are using multiple database: MongoDB, Oracle DB, Postgres, Redis, S3 bucket. Each database having specific use. So for example, customer services, customer data always will be unstructured, and it will be used to manage unstructured data, will use MongoDB. And whenever any transactional, like acid complaints, very strong secure transaction is happening, that time say this Postgres or Oracle will be useful for that. Okay, so Postgres will be less costly as compared to Oracle in corporate level. So many project or many banking the sector, they are migrating from Oracle to Postgres. They both are almost same. So here we are using S3 bucket for generating statement and generating report for particular customer. If you think about a bank, so in a bank we are having millions of customers, and they are having data. They want a world record, somebody's taken some loans, all the record is maintaining, and sometimes they need some reports. Customer requested for 5 years or 10 years of bank statement. In that case, the bank will take the request and it will process it, and in that case he will do that kind of services. They will use the S3 bucket, is very suitable and feasible for it to manage that huge large number of large data. Okay, so it will come in GBTB and all, because millions of customer, how much data you think. And some of the cases we need frequent access, so there we will use cache data, Redis DB we are using. So we are, as I told you, many more, like 20 to 25 microservices we are using in our application, and each microservices having specific functionalities, handling specific flows, and sometimes microservices communicating to each other. That is very required actually. Sometimes the your project architecture and dependence will be more because of more microservices communicating to each other. So here I told you like three layer: UI layer, microservices layer, and database layer. And in between, your API gateway is working actually. So Kong is working to handling the rate limiting, logging, and authenticating, load balancing, scaling, all these things in infra level it is doing. Okay, but in application level, each microservices, whenever it will be like you wrote some code and you commit, so thereafter it will be like you are using CI/CD, continuous integration and continuous deployment. So once you commit some code and code review done and you deployed, sorry, you code review done and you merge into the branch, automatically a image will be created as you return the Docker file for each microservices. Image will be created and it will be stored in the artifact. Okay, so in that artifact ID, that continuous integration is done. From that artifact ID, that image will be picked by Kubernetes and it will be deployed into the, that is continuous deployment. It will be deployed into a architecture layer, that is Kubernetes. You can use ADO, Azure DevOps, or automatically without using in the CI/CD Jenkins also it is happening. You can use Kubernetes to manage that. Okay, so you can say you are using Docker because you wanted to containerize your each microservices image, so that you will be make sure that your image is independently running. It is not dependent on platform. It is, you take your image, it is running in dev environment, stage environment, UAT, then production. No, you are using Kubernetes because whenever your application running multiple microservices, multiple container created, sometimes it has to be auto scale as per your need and request. Okay, so that Kubernetes is managing multiple container. It will run like, it will increase your the number of instances as per the request. Okay, so that each instances it will run inside a pod. So suppose your payment services need more attention now, multiple people doing a payment, or order service, multiple people doing some orders in offer times and all. So that times it will enhance and scale in horizontally, vertically, all these things like multiple pods, multiple containers will be increased. And if Kubernetes is managing all the container, all the instances, okay, so it will run. If any pod is damaged, it will restart, and at a time it will restart some or multiple pods, multiple instances, all these managing kind of things. Actually, inside pod, your container will be there, and inside node, one pod is there. So a node can have one pod or multiple pods, will have multiple nodes. And cluster means a Kubernetes environment is known as cluster. Okay, so the example will be like this. I will show you. I told you we are having node. Inside node you are having pod. Inside pod you are having container. So sometimes a one pod having multiple container. Suppose DB having multiple container. So similar container will have that kind of things. Generally one container, one primary container will be there. So multiple container, like multiple pod, it will be run work together, and multiple pods in a node and multiple nodes in a cluster. So this will be managed by Kubernetes, all these things to scale, auto scale. And in the application level it is doing all these things like Docker cannot manage. It's like a manager, because multiple instance or container, it has to be start. So multiple instances work together whenever we need. It is scaling the number of instances. Who is doing that? So this Kubernetes is taking care of it. So it is managing actually. So all this orchestration layer it is doing, this Kubernetes. And you see here this one I was telling about the CI/CD. So whenever you commit a code and merge it, it will be start building, then testing, unit test it will happen. At the time of unit test it will check the code quality, sonar cube and all. JUnit test, whatever you wrote it will run. If anything it will fail, otherwise it will generate the build image and all. It will be stored in artifacts. And then in continuous deployment it will deploy in staging, dev staging, then UAT, then productions. So this deployment things is managing by Kubernetes. Okay, that's what I wanted to say. So you see this diagram now, you will be more clarity. I'm little bit speed whatever I'm speaking, but any doubt you can ask me. You can direct message me in LinkedIn. So here in I have given my LinkedIn profile, so you can directly message me any more doubts. So the video will be lengthy, that's what I'm speaking very speedily. So you can reach out to me and you can put some comment, whatever you need to explain, I will explain. So here why you are using JWT, I already explained. It is very lightweight, stateless. It is not storing anything. A token is generating and it is up to 15 minutes. It will be not expire and you can make any call of any API. It will be directly attached to your request. And Docker you are using to make containerization, to make platform independent, and Kubernetes to manage all the instances. So here deployment is happening. Okay, so you can use CI/CD, or even on top of CI/CD you can use this ADO, Azure DevOps. So all these things you need to explain why you are using Spring Boot having multiple features to develop a microservices application. So each microservice is nothing but a Spring Boot applications, right? So it is lightweight and you can no need to manually configure it. Many more features are there in Spring Boot, you know. So now you see, apart from this, what you are doing in your project, you are doing some logging, you are doing some tracing and metric kind of things. So we are using ELK for logging, like elastic logs test, like any logs, any things happen, you are logging, right? So we are using this ELK component in AWS. And Grafana we are using for like visualization kind of things. You wanted to metric the logs where the exact error is coming and all. Jepkin you are using, suppose service A is calling to service B, service B is calling to service C, internally service C is calling service D, something like that. But whenever you call from service A and it is failing, you don't know which service is really failing internally. Maybe service D is failing or C is failing, you are not aware of it. To track that you are using Zipkin, it is just tracing track and all these things. So for observability and monitoring your applications, you are using, these are the tools you can say. So you have to know each tool, you have to know each technology, whatever I mentioned here. You need to read how Apache Kafka is working. So even you can add few more technologies in your banking application, right? RabbitMQ and lot of more AWS components you can use. I have used very few here to make it very easy, and a basic architecture of a banking domain. At least if you are working in a banking project or this banking sector, so you should have knowledge on this project architecture and what are the technology I mentioned. You should have a basic knowledge why you are using, what is the purpose of that. So I think this video will be helpful to all of you to understand a basic flow of your applications. And definitely after explaining these applications, they will ask a few cross question like what are the challenges you faced in your microservice based application development. So why you were using this Kafka, or all these things. I'm going to clear little bit more depth about each individual technology or each individual question in a different session. So I think this session will be very useful to you. If any doubt, please let me know in comment section. You can reach out to me in my LinkedIn direct message you can put. And if you really satisfied by understanding something, or if your opinion something different, you can put a comment. Please subscribe this channel, it will be really helpful to growth and to upload few more videos for you. Thank you so much for watching. I will meet in some other videos.